Chapter 1 provides the introduction to the architecture of the manufacturing planning and control (MPC) systems. There are three key questions that this chapter answers. First, what is the manufacturing planning and control framework? Second, how do firms match their needs to the appropriate MPC system? And third, how does an MPC system evolve? Figure 1.1 is a schematic of the general MPC system that would be used within a firm for planning and controlling its manufacturing operations. The figure is divided into three parts or phases. The top third, or front end, is the set of activities and systems for overall direction setting. This phase establishes the overall company direction for manufacturing planning and control. Demand management encompasses forecasting customer, end product demand, order entry, order promising, accommodating interplant and intercompany demand, and spare parts requirements. In essence, demand management coordinates all activities of the business that place demands on manufacturing capacity. Sales and operations planning balances the sales, marketing plans with available production resources. The result is an agreed-on company game plan that determines the manufacturing role in meeting company strategy. Increasingly, this activity is receiving more management attention as the need for coordination is recognized in progressive firms. The Master Production Schedule, MPS, is the disaggregated version of the Sales and Operations Plan. That is, it states which end items or product options manufacturing will build in the future. The MPS must support the Sales and Operations Plan. Resource planning determines the capacity necessary to produce the required products now and in the future. In the long run this means bricks and mortar, while in the short run it means labor and machine hours. Resource planning provides the basis for matching manufacturing plans and capacity. The middle third, or engine, in Figure 1.1 encompasses the set of MPC systems for detailed material and capacity planning. The Master Production Schedule feeds directly into the Detailed Material Planning module. Firms with a limited product range can specify rates of production for developing these plans. However, for firms producing a wide variety of products with many parts per product, detailed material planning can involve calculating requirements for thousands of parts and components, using a formal logic called Material Requirements Planning, MRP. MRP determines, explodes, the period-by-period, time-phased, plans for all component parts and raw materials required to produce all the products in the MPS. This material plan can thereafter be utilized in the detailed capacity planning systems to compute labor or machine center capacity required to manufacture all the component parts. The bottom third, or back end, of Figure 1.1 depicts MPC execution systems. Here, again, the system configuration depends on the products manufactured and production processes employed. For example, firms producing a large variety of products using thousands of parts often group all equipment of a similar type into a single work center. Their shop floor system establishes priorities for all shop orders at each work center so the orders can be properly scheduled. Other firms will group mixtures of equipment that produce a similar set of parts into work centers called production cells. For them, production rates and just-in-time (JIT) systems for execution are appropriate. The supplier systems provide detailed information to the company suppliers. In the case of arm's-length relationships with these suppliers, the supplier systems will produce purchase orders that will be transmitted to the suppliers. Thereafter, the company MPC systems should provide suppliers with updated priority information, based on current conditions in the company, as well as in their customers' companies. In the case of closer, partnership, relations with suppliers, information can also include future plans, to help the suppliers understand expected needs. In a general sense, the receiving end of this information is the demand management module of the front end in the supplier's MPC systems. Figure 1.2 shows the relationship between MPC system approaches, the complexity of the manufactured product as expressed in the number of subparts, and the repetitive nature of production, expressed as the time between successive units. Figure 1.2 also shows some example products that fit these time and complexity scales. Several MPC approaches presented in Figure 1.2 are appropriate for products that fit in various points in the schema. The figure demonstrates that the MPC emphasis changes as the nature of the product, process, or both change. For example, as a product's sales volume grows over time, the MPC emphasis might shift from right to left. Regardless of where the company is on Figure 1.2, it's necessary to perform all the activities depicted in Figure 1.1. However, how they are performed can be quite different for firms at different points on Figure 1.2. The lower left-hand corner of Figure 1.2 shows a flow-oriented manufacturing process typical of many chemical, food, petroleum, and bulk product firms. Because products are produced in streams instead of discrete batches, virtually no time elapses between successive units. With these processes, the front-end concern of the MPC system is primarily the flow rates that become the master production schedule. Typically, these products have relatively few component parts, so engine management is straightforward. Depending on how components are purchased, the back-end may involve some complexity. Typically, these firms' major cost is for raw materials, although transportation costs can also be significant. Repetitive manufacturing activities are found in many plants that assemble similar products, for example, automobiles, watches, personal computers, pharmaceuticals, and televisions. For such products, component part management is necessary, but everything is coordinated with the flow or assembly rate for the end items. In the middle of the figure we show a large application area for just-in-time systems. Using lean manufacturing approaches, many firms today try to move their processes from right to left in the figure. That is, they try to make processes more repetitive as opposed to unique in order to achieve the operational advantages of repetitive manufacturing, shorter production cycles, reduced lead times, lower inventories, and the like. JIT is shown as spanning a wide variety of products and processes. This MPC approach is increasingly being integrated with more traditional MRP-based systems. The goal is to achieve better MPC system performance and to reduce costs of maintaining the MPC system. Figure 1.2 also shows material requirements planning as spanning a wide area. MRP is often the platform for ERP applications and is key to any MPC system involving management of a complicated parts situation. The majority of manufacturing firms have this sort of complexity, and MRP-based systems continue to be widely applied. For many firms, successful use of MRP is an important step in evolving their approaches to MPC. Once routine MRP operation is achieved, portions of the product and processes that can be executed with JIT methodologies can be selected. The last form of MPC depicted in Figure 1.2, the project type, is applied to unique long lead time products, such as ships and highly customized products. Here, the primary concern is usually management of the time dimension. Related to time is cost. Project management attempts to continually assess partially completed projects' status in terms of expected completion dates and costs. Some firms have successfully integrated MRP approaches with the problems of project management. This is particularly effective in planning and controlling the combined activities of engineering and manufacturing. Figure 1.3 depicts some manufacturing firms' typical responses to changing marketplace dictates. New technology, products, processes, systems, and techniques permit new competitive initiatives. Global competition intensifies many of these forces. Marketplace dictates drive revisions in company strategy, which in turn often call for changes in manufacturing strategy, manufacturing processes, and MPC systems. Shorter product life cycles come about partly because consumers have access to products from all over the world. This has spawned the move to time-based competition. Who can get to the market quickest? Similarly, today's market insists on ever higher quality, which in turn has led to many changes in manufacturing practices. Cost pressures have translated into reductions of all manufacturing cost components from material and labor to overhead and energy. But increasingly, cost and quality are the ante to play the game. Winning requires flexibility and responsiveness in dealing with even more fickle customer demands. Clearly, these pressures and responses require changes in both the MPC system and the underlying manufacturing process. As Figure 1.3 shows, typical MPC responses are MRP and JIT. Process responses include automation, simplification, and production cells for cellular manufacturing. If the MPC system has remained unchanged for a significant length of time, it may no longer be appropriate to the company's needs. The system, like the strategy and processes themselves, must change to meet the dictates of the market. In many instances, this may simply imply a different set of evaluative criteria for the MPC system. In other cases, new modules or information may be required. In yet other cases, entire MPC activities may need to be eliminated. For example, JIT systems frequently move materials so quickly through the factory that MRP and shop floor scheduling systems to track them are not needed. In supply chain management approaches, the emphasis shifts to the total costs and values created in the joint activities of more than one firm. The typical focus is on the dyad, two firms where time and inventories are substantially reduced. The need for evolution in MPC systems implies the need for periodic auditing that compares system responses to the marketplace's requirements. The audit must address not only the system's focus but also the concomitant training of people and match with current objectives. Although the MPC framework in Figure 1.1 is general, its application is specific and evolving. Keeping it on track is an essential feature of MPC itself.